these problems we're going to find average rate of change again, but rather than being provided a function, we're actually provided a partial set of values for the function. So in this case they want us to find the average rate of change from -1 to 2. So it's the same concept. We'll have -1 comma something and 2 comma something, but it's a little easier this time because as long as they gave us the point, we don't have to figure out what the other value is. I know -1, -3 go together, and I know that 2 corresponds with 6 in this one. So very simply, I have my x1, y1, and x2, y2 quicker on this example right here. Okay, so in this one we have this being x1, y1, this being x2, y2, and again I just want to find the average rate of change. So m is equal to y2 minus y1 over x2 minus x1. So that's equal to 6 minus -3 over 2 minus -1, which 6 minus -3, that'll be 9, and 2 minus -1, that'll be 3. And so that's 3 for the first one. Alright, so for this next one, maybe I need to fill that in a little bit. That should be 5. Alright, so we need to find again the points that fit for this. So we're going to have -1 comma something and 2 comma something. And again for this we just can look at the fact they gave us -1, so it's -1 comma 1, and they give us the point that corresponds with 2, so it's 2, 7. And so if I want to find the average rate of change, I have x1 and x1 and y1. And x2 and y2. I don't know why it keeps making those disappear up there, but that should be 5 and that should be 7. Alright, so then we can do the slope now, since m is equal to y2 minus y1 over x2 minus x1. That's going to be equal to 7 minus 1 over 2 minus -1. So 7 minus 1 is 6, and 2 minus -1, that would be 3. So 6 divided by 3 is 2, so the average rate of change is 2 between those two. Alright, then on the last one, we'll do the exact same thing yet again. We'll have -1 comma something, because we're going from -1 to 2, and 2 comma something, and up here we'll have -1 comma -2 and 2 comma 5. So again, that's x1, y1, that's x2, y2, and so m is equal to y2 minus y1 over x2 minus x1. So that's going to be equal to 5 minus -2 over 2 minus -1. So 5 minus -2 would be 7 over 2 minus -1, which would be 3. And 7 divided by 3 is basically 2.3 repeating, but again you can use your calculator if you like. So you can see I get 2.3 repeating. And if you wanted, we could actually go back and look. I think you'll find this is a quadratic, this is a linear, and this is exponential. And it likes to keep making those numbers disappear. Alright, so in this case, which one's the fastest growing? It looks like it would be a of x, because it grew by a factor of 3, or an average rate of change of 3. It says, consider the table below, which shows a partial set of values of two continuous functions. Based on the x provided in the table, which function always has a larger average rate of change? Well, we can kind of just look at the rate of change between each of these. So from -2 to 0, the rate of change, it jumped by 1 here. So you can see the x's are always jumping by 1. So 0 to 1 is 1, and 1 to 2 is 1. So all those are 1. So the rate of change for this first one, from -2 to 0 is up by 2. And then from 0 to 3 is up by 3, and from 3 to 7 is up by 4. And then let's compare it with this one now. This one is growing by -4 to 0, that's going up by 4. So again, that one won, this is higher. So between again we're kind of comparing like who's higher. 4 is faster. And then from 0 to 8 it increased by 8, so the comparison is 3 or 8, who's growing faster? 8's growing faster. And then from 8 to 24, that's up by 16. So is it 4 or 16? 16 is growing faster. So in every one of these steps, g of x was growing faster, so it has a faster average rate of change. All right, now we're going to be asking to find an average rate of change from x equals 1 to 3, given the graphs. All right, so same concept again. We're going to probably very easily find the 2 points, because we have 1 comma something and 3 comma something, so we're going to look on the graph here. So the first one is 1 comma -3 and 3 comma 3. So there's two ways we can do this. We can use the graph to find it, or we can use the equation. So we can do y2 minus y1 over x2 minus x1, which in this case would be 3 minus -3, over 3 minus 1. And you can see that's x1, y1, x2, y2. So this would be 6 over 2, which is 3. The other way we could have done that is we could have just figured out we're rising up 1, 2, 3, 4, 5, 6. So there's a rise of 6 and a run of 2. So rise over run would be 6 over 2, which is still 3. So maybe a little faster to do that visually. But I'd like to do it both so we can compare the two. All right, so the next one again. We're going to start with the points basically 1 comma something and the point 3 comma something. So on the graph, there's the first point, 1 comma negative 4. And the point 3 comma 4 is right there. So there's x1, y1, x2, y2. And so once again, m is equal to y2 minus y1 over x2 minus x1, which is equal to 4 minus negative 4 over 3 minus 1, which that would be 8 divided by 2, which is 4. Again, you can kind of see the line between those. That would be up 1, 2, 3, 4, 5, 6, 7, 8, and over 2, which is 8 over 2, which is 4. All right, the last one, a line. Again, we're going to use the same two starting points for x. So we have 1 comma something and 3 comma something again. And so at 1 comma something we have right there, it's 1, negative 2. And 3 crosses right at the line, so it'd be 3, 0. So that's x1, y1, x2, y2. And so this would be m is equal to y2 minus y1 over x2 minus x1, which is equal to 0 minus negative 2 over 3 minus 1. So that would be 2 over 2, which is equal to 1. And again, I could have done that by just drawing a line from going up 2 units and to the right 2 units, which is 2 over 2 rise over run, so it's 1. So in this case, you can see that it turns out that this function right here, b, which is f of x, if you look at the graph right there, I guess f of x is the one that's growing the fastest. All right, so it's just average rate of change, and we're comparing it between functions. If you go far enough to the right, the exponential function always wins, but if you're somewhere in the left-hand side or the middle, you could actually have like the quadratic or linear win to be the one that's growing faster. I'm going to stop here and I'll start the next video in just a moment. Good luck on your quiz. Ask your teacher also if you have any questions.